Okay, we are going to discuss rules for divisibility as they are done in Vedic math. This is video number 6. It's a sixth video in a series. Okay, let's continue. Okay, we will discuss the topic in various sections, and first section is divisibility by first principles. Okay, in division we divide the dividend by a divisor, but to get quotient and a remainder. Okay, let's see how problem looks like. We have a dividend. We divide the dividend by the divisor to get a quotient and a remainder. Okay, divisor is like this, is what divides the dividend, and answer is quotient with the remainder at the end. Okay, let's continue here. In divisibility, a dividend is divisible by divisor if the remainder is 0. It's a matter of remainder being 0 or not. Okay. Observation. Divisibility is matter of remainder being 0 or not. So we'll concentrate in this section more on. Let's look at first principles regarding divisibility. First, 0 is divisible by any number except by itself. Okay? Any number is divisible by itself except when the number is 0 or infinity. Okay, let's continue. A number is divisible by 1. So these are the first principles. We don't have to go to any test here. Just say 0 is divisible by any number except itself. A number is divisible by itself except when the number is 0 or infinity, and a number is divisible by 1. Okay, let's go to next section. And next section is divisibility by remainder. So we'll try to find remainder of the problem. When we are trying to divide dividend by divisor, we try to find remainder and see if we can get a remainder of 0 or not. See, testing remainder now. Divisibility by 2. We're going to use the example here. A number is divisible by 2 if it ends in 0, 2, 4, 6 or 8. Okay, that's from multiplication table. The multiplication table for 2, all the entries end in either 0 or 2 or 4 or 6 or 8. Let's continue. Note that 10 is divisible by 2, and 10 divided by 2 is 5, remainder 0. When we divide a number by 10, the remainder is the last digit. Now we need to test the last digit for divisibility, and that's what we did in the previous paragraphs. Okay, we just say ends in 0, 2, 4, 6, 8. That's the last digit was such and such, and we did that because to get last digit we found a remainder by dividing by 10. Okay, so let's continue. Example, is 364 divisible by 2? Remainder is 364 divided by 10 is 4, and 4 is divisible by 2, and so is 364 because 4 is 2 times 2. Example, 7891 divisible by 2. Remember, remainder of 7891 divided by 10 is 1, the last digit, and 1 is not divisible. Okay, let's continue with testing remainders. Okay, first we'll discuss here divisibility by 4, and we will see if a number is divisible by 4. Let's continue here. First we note that 100 is divisible by 4 because 100 divided by 4 is 25, remainder 0. What I mean is 100 is a multiple of a 4, and it's actually 24, 5 times 4. Okay, so let's continue here. Then 20 is divisible by 4. That means 20 is a multiple of 4, and in fact 20 is equal to 4 times 5. Okay, let's continue here. First we get remainder from dividing by 100. So what we are trying to do here is, from the given number we subtract all the hundreds we can, and whatsoever left over is the same thing as remainder from dividing by 100. So whatsoever we left over is the remainder is the one we are going to use in the next step. Okay, let's continue here. So we'll discard the quotient part of the division, we just keep the remainder part. Second, we use that as a dividend for division by 20. What's the remainder I got from first step? I take away all the 20s I can, discard, and that's the same, and see what's left over, this remainder. And it's the same thing as if I divided that remainder here by 20 and discard the quotient and keep the remainder. Okay, we are interested in the remainder only. Let's continue. Third, we check the remainder for divisibility by 4. So first I take away all the hundreds and keep the remainder. Then I take away, from that remainder, I take away all the 20s I can and keep the remainder, discard the quotient. And then I see that what's the remainder from second step is in 0, 4, 8, 12, or 16. Or I can take away all the 4s from here and see, to get a 0. Okay. So the way mechanism here is subtract multiples of the divisor, as many multiples I can, and arrive at a remainder and see if a number we finally arrive at is divisible by 4. And that's the mechanism. We subtract the multiples of the divisor, 4 in this case, as many as I can, as fast as I can, so that I can arrive at a remainder and as quickly as I can. Okay, and so if it's a remainder is in 0, 4, 8, 12, or 16, after I subtracted multiples of hundreds and then multiples of 20s, okay, to get at a remainder which is less than 20. And if that remainder is in 0, 4, 8, 12, and 16, okay, examples. Is 789 divisible by 4? Okay, okay. It's not even divisible by 2, and Tirthaji would say that is out of code, and we don't need to consider that. 789 is not divisible by 4. 789 is not divisible by 4. Let's continue. Is 72780 divisible by 4? Okay, let's continue here. Step 1. A remainder of 72780 is 80. We just, I drew this line here to separate out last 2 digits. Okay, and that's the remainder. This is how we divide by 100. 727 is the quotient and 80 is remainder. Let's continue. Remainder of 80 divided by 20 is 0. So 80 is, if you divide 80 by 20, remainder is 0, and 0 is divisible by any number. 0 is divisible by 4, and so is 72780. So 72780 is divisible by 4 because 0 is divisible by 4, and 0 is our last. Continue. Example is 56895 divisible by 4. Okay. 56895 is not even divisible by 2, so it's not divisible by 4. Okay. Is 40928 divisible by 4? So we go through the steps. Okay, first we divide by 100 and get a remainder. Remainder of 40928 divided by 100 is 28. The way we divide by 100 is separate our last 2 digits, draw a line to the left, and the number on the left is the quotient, and the one on the right is the dividend, remainder. Remainder is 28, quotient is 409. So remainder is 28. Let's continue here. After that, we take this remainder here and find its remainder when we divide that by 20. So remainder of 28 divided by 20 is 8. Okay, and let's continue. 8 is divisible by 4, and so is 40928. So I went through these steps here, and you could have combined the steps. First of all, look at 28. If you say 28 is divisible by 4, you didn't have to go through the next step here. Okay. Okay. Let's and also you can look at this number here, 40928. We got 28 here, the last 2 digits, those are remainder. And to divide by 20, take a remainder, this 2 disappear, 2 becomes 0 here. We take 20 out of 28, leaving 8. So you could have said Right from here, it's a 8 would be the last remainder, and 8 is divisible by 4, and so is 40928. So with practice, you will be combining these steps. I have to go through these steps so that you know what is involved. Okay, let's continue. You should be combining the two remainders and write down the final remainder by observation. Take away. Okay, what's what you need to do? You need to combine. Okay, you can combine divisible by 8. Okay, note that. Let's see what you're going to do. 1000 is divisible by 8. So 1000 is divisible by 8. Let's see what happens. 200 is divisible by 8. Okay, 40 is divisible by 8. So we're going to use this information here, that 1000 is divisible by 8, 200 is divisible by 8, 40 is divisible by 8, and then let's see what happens. So a number is divisible by 8 if the remainder, last remainder of number divided by 40 is in 0, 8, 16, 24, 32. And it's up to you if you wish to go through the steps or combine the steps. Okay, let's continue here. Is 511 300 divisible by 8? Okay, let's continue. First we do remainder by 1000. So 5111 300 divided by 1000 is, remainder is 300. The way we divide by 1000 is separate out the last three digits and draw a line to the left of it. So that's what the one on left 511 is a quotient, and on the right 300 is a remainder. Let's continue. Next step. Remainder 300. If I take this 300 as dividend and divide by 200, and that's remainder is 100. Okay, next three. Remainder of 100 by 40 is 20. Okay, let's continue here. 20 is not divisible by 8, and neither is 511 300. Examples. Okay, is 5299312 divisible by 8? Let's continue. First, what we do is we find the remainder of the number when we divide by 1000. Last three digits are 312, and that's what the remainder is. And let's continue. Then we take a 312 and find the remainder when we divide that number by 200. That remainder is 112. Okay, next three. Then we divide by 40. Okay, and see a remainder. 112 divided by 40, remainder is 32. Okay, let's continue. 32 is divisible by 8, and so is that number here. So is 5299312. So 32 is divisible by 8, and so is 5299312. Continue here. We can extend the lessons learned so far to determine divisibility of a number by 16. Let's continue. Observations. Step 1. 10,000 is divisible by 16, and subtracting a multiples of 16 does not change the divisibility. So we'll take out all the 10,000 we can, which is division by 10,000, and get the remainder. Okay, then when we take out all the 10,000 we can, what's left is a remainder from division by 10,000, and then we have to worry about if the remainder is divisible by 16. Let's continue. After we've taken all the 10,000s, we take all 2,000 we can, and then whatsoever is left is the remainder of dividing by 2,000. The remainder I got from first step, I use that as a dividend on the next step, divided by 2,000, and look at the remainder. We are in doing so, we're trying to take away all the 2,000 we can, and anything we left over is the remainder, and then we need to worry about if that remainder is divisible by 16. Let's continue. Then we know that 4,100 is divisible by 16. Then any remainder we left out by dividing by 2,000. From that, I take out all the 400s I can, and whatsoever left over is the remainder of dividing this remainder by 400, and whatsoever remainder is, now we need to worry about if that is divisible by 16. Continue. Step 4. 80 is divisible by 16, and any remainder left over from here, from step 3, we take out all the 80s we can, and whatsoever left over is the remainder of dividing that remainder from third step by 80, and what's the remainder left over is, that's what you need to worry about, if that is divisible by 16. Okay, let's continue here. A number is divisible by 16 if the final remainder here from here is divisible by 16. That means that remainder here need to be in 0, 16, 32, 48, or 64. You can do some exercises. Are the following numbers divisible by 2, 4, 8, and by 16? Let's look at some examples here. Number 9727163. Next. 2913452. Next. 3046479. Next. 1577949. Next. 1356582, and some more. Okay, let's continue here. We will check out if a number is divisible by 3. Okay, for that, let's see what to do. Recall from the digit sum discussion, a digit sum is remainder of a number 1 divided by 9. Okay, so we can compute digit sum easily, and that digit sum is in fact equal to remainder of a number when it was divided by 9, with one exception. When the remainder is 0, digit sum is 9. Let's continue. So what are we going to do? 9 is divisible by 3. Okay. So we need to first take out all the 9s we can from the number, and what's left over would be same thing as remainder of dividing that number by 9. We check that remainder for divisibility by 3. Okay, let's continue here. So let's look at example. Is 1, 2, 3 divisible by 3? First we would take out all the 9s we can from 1, 2, 3, and which is the remainder of dividing 1, 2, 3 by 9. Okay, let's continue. So we're looking for this number here, remainder of 1, 2, 3 divided by 9, and remainder of this is given by digit sum of 1, 2, 3. So 1, 2, 3 digit sum is 6. So if we were to take out all the 9s we can from 123, it would be 6. If we divide 123 by 9, remainder would be 6, and that's given by digit sum of 1, 2, 3. Okay? Now we need to check out, is 6 divisible by 3, and so is 123. So 6 is divisible, and so is 123. Let's continue. Let's continue and discuss divisibility by 6. If a number is divisible by 6, let's investigate it. Note that 6 is a composite number, which by what I mean is that it's a product of 2 and 3. Okay? Let's continue. A number is divisible by 6 if and only if it's divisible both by 2 and 3. So we have to check the divisibility by 2 and also by 3. Okay? Let's continue here. For divisibility by 2, a number has to be even, which, okay, if a number is even, it's divisible by 2. If a number ends in 0, 2, 4, 6, or 8, it's divisible by 2. Let's continue. For divisibility by 3, refer to the previous section, okay, which is we check out the digit sum, and then whatsoever that is left over is that remainder divisible by 3. Okay, let's continue here. So let's take an example. 4 to 6. Is that divisible by 6? Okay. The two tests we need to do is a composite number. Is it even? It is even. It's divisible by 2. So first test is passed. This test here for divisibility by 2, that passes. Let's continue and see if for divisibility by 3. Okay, let's continue here. Remainder of 426 divided by 9. So we're going to take out all the 9s we can, and whatsoever is left over is remainder from dividing 426 by 9, and that is 3 from the digit sum. Okay, and that 3 is divisible by 3. So we passed the first test of divisibility by 2, and we passed the second test of divisibility by 3. Okay, so that means 426 is divisible by 6. Let's continue. Okay, now let's discuss divisibility by 9. For divisibility by 9, remainder from division by 9 has to be 0. That means When we take away all the 9s we can, the leftover should be 0. Okay. Recall from digit sum discussion, when the remainder from division by 9 is 0, digit sum of that number is 9. Okay. Let's continue. A number is divisible by 9 if it is digit sum is 9. So from this discussion here, we know that if a number is divisible by 9, if its digit sum is 9. Let's continue. Let's look at an example here. Is 234 divisible by 9? Let's continue here. So when we take away all the 9s we can from 234, it's the same thing as dividing 234 by 9, discarding the quotient and keeping the remainder. And that remainder is also given by digit sum of the number 234. Digit sum of 234 is 9. Okay. And we say that if a if the remainder is a 0, the digit sum is 9. So digit sum I get 9, so it's a divisible by 9. That means 234 is divisible by 9. Let's continue. For exercises, refer to the digit sum section. I gave a link. I'll continue and discuss divisibility by 5. Okay. Divisibility by a number is divisible by 5. It ends in either 0 or in 5. Okay. Let's continue here. So let's see what we did. We are doing by remainder. So 10 is divisible by 5 because 10 divided by 5 is 2 remainder of 0. That means 10 is equal to 2 times 5. That means that we would try to take away as many 10s as I can and as fast as I can from the number. What's left over is a remainder. It's the same thing as if I were to divide a number by 10, like divide 10 and discard the quotient and keep the remainder. We need to check that remainder for divisibility by 5. So that remainder what's left over is there are only two single digit numbers divisible by 5, and those are 0 and 5. In fact, as soon as when I start taking tens away, as soon as I can decide that number is divisible, I don't need to take away anymore. But if I need to continue to see if the remainder is 0, I can subtract 5 from this 5 here and also get a 0. So but we know that 0 is divisible by 5 and so is 5, and I don't need to do any more subtractions. Let's continue. Example, is 6896 divisible by 5? Let's continue here. First step is we're going to take away all the 10s we can. Okay, and the way we do that is 6896 and we get try line to the left of a 6 here, and the one on the left is a quotient, the on the right is a remainder. Remainder is 6. Okay, let's continue. 6 is not divisible by 5. It's not in this list, in the set of 0 and 5. So, and neither is 6, 8, 9. Another example. Okay. So what's the largest number having one occurrence of 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9 each, such that it's divisible by 2, 3, 4, 5, 6, 8, and 9. Let's continue here. Largest number with all these digits is largest digit on the left and smallest digit on the right, and in this descending order. So 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. So this is largest number consisting of one each of these digits we had in mind. Okay, let's continue. Is this this is divided by 2. First I'll check its digit sum. Its digit sum of the number is 9. So and it's even. So it's divisible by 2, 3, 6, and 9. It's also divisible by 5. Okay, let's continue here. To make the but it's not divisible by 4, okay, because 10 in the last two digits is not divisible by 4. But if I change that to 20 by interchanging 2, 1 to 1, 2, then that's divisible by 4 also. Let's continue here. That number is now is after the exchange here, 9876543120. Instead of 210, we have it now 120. Let's continue here. Now this number is divisible by 2, it's even. Divisible by 3, its digit sum is 9. It is divisible by 4, where the last two digits are 20, which is divisible by 4. 5, it ends in a 0. 6, it's even and digits sum is 9. 8 is 120, the three digits in the right are divisible by 8, and a 9, its digit sum is 9. Okay, let's continue and discuss divisibility by 11. Okay, recall that we use digit sum for a number to obtain remainder from dividing by 9. Okay, let's observe here. 9 is 1 less than 10 and we added the digits. Okay. 11 is 1 more than 10 and we need to subtract the digits in some way. Okay, let's continue here. I'm going to define a term called digit difference. I have not seen it, the term, in any of the books I have looked into, and I'm going to define that as difference, but it's continued difference of digits in a number is its digit difference. So digit sum was sum of the numbers, and digit difference is difference of the digits in the number, but it's a continued difference. And the digit difference is the remainder from division by 11. So digit sum is remainder from division by 9 here, and digit difference is the remainder from division by 11. And we use next slides to explain what I mean by the digit difference. Okay, I have not seen the term in any of the textbooks I have seen. Okay, let's continue. Let's look at the digit difference. First, we considered a number. Number is a linear combination of the natural base numbers. Natural base numbers are power of 10, and this is the multiplier for linear combination. We are looking at integers only. A is integer, and smallest value of I is 0. Okay, let's continue. And I define digit difference of which dd is a0, the first coefficient, minus parenthesis second coefficient a1, minus parenthesis next higher coefficient a2, minus parenthesis a3. Now let's sort them out. So a0 is positive. Okay, a1 has a minus here, is negative, so minus a1 is in the parenthesis after the minus sign a1. A2 is positive, minus and minus, make it positive. A2 is positive, but A3, 1, 2, and 3 minuses. So A3 is negative. So these are the coefficients of the even terms. Even terms mean terms which of the even power of 10. Okay, and these are the odd terms. Those are the coefficients of the odd power of 10. Okay, let's continue here. So let's look at number line again, from starting from 1 and compute their digit difference using this equation here. Okay, 1 single digit, nothing to subtract from, it's a 1. 2 single digit, 2. 3 single digit again, 4 single digit again, 5 single digit again, 6, 7, 8, 9, 10. Now we got 2 digits. Okay, 10 is 2 digits. This is a0 is a 0 and a1 is a 1. So we got a0 minus a1. Digit difference is minus 1. Let's continue with 11. We got 1 and a 1. 1 minus 1 is 0 and 0. So in digit sum, we could not get a value of a 0. In a digit difference, because we were adding that time. Now we are doing some kind of subtractions here. So we got 0 I can have. No problem with 0. 12 is a 1. So 2 minus 1 is 1. We started with 1. We came back with 1 and we repeat. So this is a period here and repeats after on 12th term. Okay, and period is 11. So this dd is periodic and a period is 11. So digit difference repeats after 11 entries. So period is 11, and when you can resolve minus 1 now. Replace minus 1 by minus 1 plus 11, which is equal to 10. Let's continue. Okay, so digit difference of 10 was minus 1, which we can replace by 10. Okay, let's continue with 13. Digit difference is 3 minus 1, which is 2. With 14, it's a 4 minus 1, which is 3. 15 is a 5 minus 1 is a 4. 16, it's a 6 minus 1 equals 5. Okay, and you can verify for yourself that numbers in the digit second row are remainder when a corresponding number in the first row is divided by 11. Okay, so dd of number is remainder when number is divided. Okay, when a digit difference is more than 10, we repeatedly compute digit difference to arrive at a number in 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Let's continue. Again, when digit difference is less than minus 10, repeatedly compute digit difference again. And if the digit difference obtained so far is negative, add 11 to make that positive. Okay, and then it would be in this from 0 through 10. Let's continue. Now, divisibility by 11. A number is divisible by 11 if digit difference of that number is 0. Okay, a number is divisible by 11 if its remainder when we divide it by 11 is 0, and we already figured out that when remainder is a 0 and so is a digit difference. Okay. Okay, let's continue and have some examples. Example, compute digit difference of 3453. Let's continue here. So that means 3 is A0 and A2, 3 plus 4 and minus A1, which is 5 and 3. So 3 plus 4 is 7 minus 5 plus 3 is 8. So it's 7 minus 8, which is minus 1, and minus 1, then we can add the period to it. Minus 1 plus 11 is 10. So digit difference of 3453 is a 10. Okay. We did not have to redo the digit difference of 10 because we have a reasonable number which is between 0 and 10. Let's continue. Let's do another one. 3453 and divided by 11 is 313, remainder 10. So remainder is 10, and that was digit difference that verifies that even in this example, the digit difference is same thing as the remainder of when we divide by 11. Okay, let's continue. Well, another example here, dd of 24867. Now we have 5-digit number. Okay, that means let's see what's going on here. So for positive terms are 7, 8, and a 2. 7 plus 8 plus 2 is 17, and negatives are 6 and a 4. So it's 17 minus 10, which is 7. Again, I don't have to redo the digit difference because digit difference obtained so far is 7, which is within 0 and 10. Okay, let's continue. And if you did divide by 11, which is 2260, remainder 7. This remainder 7 still matches with the digit difference 7. So it still verifies that digit difference is the remainder when we divide by 11. Some more examples. Example 1, digit difference of 1, 2, 3. It is 3 plus 1 minus 2. 3 minus 2 plus 1, which is 2. Okay. Okay, and if you divide 1, 2, 3 by 11, it's 11 remainder 2. So this digit difference still matches with 2 in this example also. It still verifies that our assumptions that digit difference is equal to remainder when number is divided by 11 is still holds. Okay, it's still verified. So let's do another example. Digit difference of 5752212, which is equal to 2 plus 2 plus 5 plus 5. 2 plus 2 plus 5 plus 5. It's a 4 and a 10. 14 minus this minus side here. 1 plus 2 plus 7. 1 plus 2 plus 7 is 10. So that is 4. 14 minus 10 is 4. Let's continue here. Let's look at the, if we divide 5752212 divided by 11, I do get the remainder 4. So digit difference still verifies that it is equal to remainder. Remainder is 4, so is the digit difference. Let's another example here. 3 digit difference of 8861,023. Let's continue here, which is equal to 3 plus 0 plus 6 plus 8. 3 plus 0 plus 6 plus 8, which is equal to 6 plus 6 is 9 plus 8 17 and minus 2 1. 2 plus 1 is 3 and 8 11. So it's 17 minus 11 is 6. Let's continue here, and it still matches. 8861,023 divided by 11 is 805547. Remainder 6. Remainder 6 still verifies and matches with the digit difference. Sizes now. Okay. Let's find the remainder from dividing the following by 11. Let's continue here. First number 4233960. Let's continue. Next 703210. Next number is 8916812. Next number is 3703887. Next number is 575973, and some more. Now discuss division by composite numbers. Let's see what composite numbers are. Composite numbers. A composite number is product of other numbers. For such numbers, divisibility test requires divisibility by its components. We have already seen one such test when we were discussing divisibility by 6. 6 was 2 times 3, okay? Product of 2 and 3. Let's continue here. Okay, so divisibility by 12. 12 is 3 times 4, and number needs to be divisible both by 3 and 4. For a number to be divisible by 12, it has to be divisible both by 3 and 4. Let's continue. Number 15. 15 is 3 times 5. For a number to be divisible by 15, it has to be divisible both by 3 and 5. Let's continue. Divisibility by 18. Note that 18 is equal to 2 times 9. For a number to be divisible by 18, it needs to be divisible both by 2 and 2. Sizes here. Okay? Are the following numbers divisible by 12, 15, 18, 22, and 24? Let's continue. First number 806657. Next number 82019. Next number 531688. Next number 720865. Next number 28833, and some more. Up summary now. We're now going to summarize the by remainder method. Let's see what's going on here. Okay, in teacher's manual, Vanna Singh's book and Glover's book cover the issues discussed here in some form or the other. Okay, let's continue. Okay, the books do not recognize that these are using remainders, and that is within the spirit of Vedic math, which is of short and sweet one-line mental solution. In Vedic math, we skip details and combine steps. Okay, let's continue here. With practice, you would be combining steps and skipping details too. That would be your second nature. This method is a direct method, and you arrive at a remainder by subtracting multiples of the divisor. Okay, let's continue next section here. Next section is divisibility by sutra, ultimate and twice the penultimate. Let's continue. Now we will discuss divisibility by ultimate and twice the penultimate. Let's see what it is. Okay, we'll use that in divisibility by 4. We want to see if the number is divisible by 4. We'll use ultimate and twice the penultimate. This is sutra that's rarely used, but it is used sometimes. So we can apply this sutra to the last 2 digits of a number. to determine divisibility by 4. Note that last two digits are remainder of the number when you divide by 100. Okay, let's continue here. Okay. Example, is 6532 divisible by 4? This line here marks the digits on left and digits on the right. We're looking for two digits on the right. Okay. So we know that 32 is divisible by 4. So this number is divisible by 4. But let's see how do we use sutra now. Okay. Last two digits are 3, 2. Okay, let's see sutra. Ultimate is, rightmost is ultimate. Penultimate is the one before that. Is so twice the penultimate of 3 times 2 is ultimate, which is the last digit 2, and twice the penultimate. Twice of 3. That's a 6. Add them together. 2 plus 6 is 8, and 8 is divisible by 4. 4 times 2 is 8. 8 is a multiple of 4, and 8 is divisible by 4. Let's continue here. That means 8 is divisible by 4, and so is 6532. If somehow you could say right here 32 is divisible by 4, we didn't have to go through those steps here. But we did want to show you the use of the sutra, that we can use this sutra to determine divisibility by 4. Let's continue. Let's do another example. This time we are trying to do divisibility by 8. So we'll check in if a number is divisible by 8, and we'll use the sutra. Ultimate and twice the penultimate. Let's continue here. Is number 97372 divisible by 8? This time we will look at last three digits. Okay. So the three digits are to the right of this line here, and the other are to the left. Okay. Let's continue here. Last three digits are 372. So what do we do here? We're going to check this number here. Ultimate is 2 plus twice the penultimate. That's 2 times 7, 14. 2 plus 7, 14 is 16. Then double of twice the penultimate. We're going to do 4 times of that. 4 times 3 is 12. 12 plus 14 is 26 plus 2, 28. Okay, so that is equal to 2 plus 14 plus 12 is 28, and 28 is not divisible by 8, and neither is 97372. 28 is not divisible by 8, and neither is 97372. Okay, all right, let's continue here. Now we'll go to next section here, where we would discuss divisibility by pseudo division. Let's see what that is. Pseudo division. To determine divisibility, we need to a remainder and see if that is 0. Okay, so in we're trying to find a remainder somehow. Okay, we will try to find remainder here and see if that is 0. Let's continue here. One way to find the remainder is by dividing, and that is what we are trying to avoid. We really don't want to divide. Okay, to achieve that without really dividing is pseudo division. Okay, please have the patience, and we will see what it is all together. Okay, together we'll see what it is. Okay. Okay, hint, we would ignore the quotient and continually attack the dividend to take away multiples of the divisor. Okay. So here's what we do. We would ignore the quotient. That's we don't care about, because we are interested in the remainder, and continually attack the dividend. Dividend is the one we divide. Okay, to take away the multiples of divisor. Let's continue. Check out the pseudo division and using an example. Okay, so where example is 780293331 divisible by 13. So we'll try to determine if a number is divisible by 13. Let's continue here. Okay, here's my cheat sheet. I wrote down multiples of 13 here, and you need to remember some of the multiples, and you don't need to remember all of those. And this is just I would need that to show you what I'm doing. Okay, so I wrote down the multiples, and you would have to remember some of the multiples here. Okay, maybe not all of them, but you should remember first 4 or 5. Okay, let's continue here. The original number is 780293331. I just added some spaces here so that I can work with it. Okay, let's continue. Identify sequence in the given number from which we can subtract multiples of 13. Okay, let's continue here. First, there's 78 here. I can subtract 78, 6 times 13 to leave 0 there. Okay, next, the sequence 29. I can subtract 13 twice. So we can subtract 26 to leave a 3 there. In 29 we will have a 0903 here. Okay, let's continue. From 33 next. From 33 we can subtract 26 to leave 7. Let's continue, see what happens. Okay, so after we did that, 78 became zeros, and 29 became 03, and 33 became 07. Okay, let's continue. Continue with the example we have. We will try to divide the number by 13. Let's see. Here's my cheat sheet. Here's the problem. Okay, and here's the original number, and here's the previous number. Okay, we started with the 780293331. After we knocked out some of the numbers here and we attacked the dividend, we were left with 73071 here. Okay, let's continue here. Now we can subtract 26 from 30 here. Okay, so 30 would have 04 in the end. Okay, let's continue here. We can subtract 65. 65 is 5 times 13 from 71. That would leave 6. Let's continue here. That means now current number is 0, all zeros here, and 406. Let's continue with the example. Here's my problem. Is this number 780293331 divisible by 13? Here's my cheat sheet, multiples of 13. This is original number 780293331. This is previous number. That's the number we ended up in on last slide. Okay, let's continue here. Subtract 30. I got 40 here. So we get 39 from 40 to leave 01. Okay, let's continue here. That would leave me 016. So I got 16 here. 16 is not divisible by 13. It's not in this list here. Okay, so neither is 780293331. Let's continue here. So 16 is not divisible by 13, and neither is 780293331. I have another example here. Example is 349349 divisible by 7? Here's my cheat sheet of multiples of 7 from the multiplication table. Let's continue. Here's the number. Original number is 349349. Okay, now from here we'll attack this thing and take away or subtract multiples of 7. Let's continue here. So I take away from 34 28. So 28 is right here, 4 times 7. So leave a 06. From 9, I take 7 away. That's 2. From 34, I take away 28, 06. From this 9, I take away 7, become 2. Let's continue. Remove multiple 7 again. From 62, I take away 56. Leave a 06. Then from 62 here, take away 06 again. Okay, let's continue. Now we'll take away something from 60 here. Let's continue. So we take away from this 60 here, I take away 56. So leave away 04. Okay, and 06 still here. Let's continue here. Then from 40, I take away 35. Leave a 05 here. So we have 56 left. 56 is in this table here. 56 is divisible by 7, and so is 349349. Let's continue. But 56 is divisible by 7, and so is 349349. Let's continue. Another example here. Example is 780293331 divisible by 7. Here's my cheat sheet, multiples of 7. Okay, let's continue here. This is the number we have. Now we'll start attacking this number and subtracting multiples of 7 when we can. Let's continue here. So first, from 7 I subtract 7, becomes 0. From 8, take away 7, become 1. From 9, this is a 29 here. From 29, I take away 28, leave a 01. Here's 33. I take away 28, leave 05. And I can leave the 1 here. Let's continue. Okay. Now, from 1010, I take away 7, become a 3 here, 03. From 10, I take away 7 again, become 03. From 51, I subtract 49. 49 is right here. Leave a 02. Let's continue. From this 30, I take away 24. 7 times 4 is 28. Becomes 02 here. From this 30 again, we take away same 28 and 02. So we get 3 zeros 2, 2 zeros 2 and 2. Let's continue here. From this 20 here, I take away 14. Leave a 06. From this 22 here, I'll take away 21. Leave a 01. Okay, let's continue now. Okay, from 60 here, I take away 56. 7 times 8. Leave a 04, and then we got a 04, 01 here. Continue. Okay, now from 40 here, I take away 35 to leave a 0, 5. So, okay, so now 51, we now left with 51 here. 51 is not in this list here. 49 is, 56 is, 51 is not. 51 is not divisible by 7, and neither is the original number, which is 78029,331. Neither is 78029,331. Another example, example 4. Example is 100000001 divisible by 17. Here's my cheat sheet of multiples: 17, 34, 51, 68, and so on. Let's continue here. This is the original number 1 followed by 7 zeros and a 1. Let's continue here. So first we remove the multiples of 17. So we take the first 100 here, 100, and remove 85 from here. 17 times 5 is 85. So 100 minus 75 is 015, and rest of them we continue 001. Okay, means 1 at the end and some zeros here. Let's continue. Now we got 150 here. From 150 I'm going to subtract 136. 17 times 8. Okay, we leave 14 here. Let's continue here. So now I got 140 here. Okay, from 140 I'm going to remove 136. Leave a 004. Okay, let's continue here. Then from 40 I take away 34. Leave a 06 here. Okay, let's continue here. Now I got 60. I got 60 here. From 60 I take away 51. Leave a 09. Okay, let's continue. From 90 I take away 85 from here. Leave a 05 here. And 51 is in this table here. 51 is divisible by 17, and so is 1 followed by 7 zeros and 1. Okay, let's continue here. Okay. And 51 is divisible by 17, and so is 1 0 0 0 0 0 0 0 1 is. Another example here is 34108735 divisible by 23. And here's my cheat sheet: multiples of 23, 23, 46, 69, 92, 115, and so on. Let's continue here. Okay. Here's original number 34108735. So we'll start taking away multiples of 23. From 34 I can take away 23. Okay, let's see what happens. So from 34 I take away 23, get 11 here. Okay, now it's a 10 and 8, 108. I can take away 92, leave a 16 here. From 73 I can take away 69, leave a 04 here. A 5 stays. Okay, let's continue here. We do same thing, remove multiples of 23. From 110 I remove out 92, leave a 0, 18. From 160 I take away 138 to leave a 022. From 45 I take away 23, leave a 22 here. Okay, let's continue. Now I got 180 here. From 180 I take away 161, leave a 019. From 222, from 222 I take away 207, leave a 15 here. Then 2 stays here. Let's continue here. From 190 I take away 184, leave a 6 here. From 152 I take away 138, leave a 14 here. Okay, let's continue here. Okay, from 60 I take away 46, leave 14 here. Then 14 still here. Okay, let's continue here. From 141 I take away 141, I take a 138, so leave a 3 here. So got 34 in the end. Okay, let's continue here. So 34 is not in this list here. 23 is, 46 is, 34 is not. So 34 is not divisible by 23, and neither is the original number 34108735. 34108735. So this number is not divisible by. Exercise here. Are the following numbers divisible by 7, 13, 17, 19, and 23? Let's continue here. Numbers are 7010044. Next. 68670. Next. 8847104. Next. 4119670. Next. 1643019. Next. 6458128, and some more. To summary here, this method is the most general method and is always applicable. Okay, it's similar to division without being a division, that it attacks the dividend to arrive at remainder. Okay, last number we got is a remainder. Okay, either a remainder or something we call altered remainder. Okay, so okay, let's continue here. It's not faster than division. We ignore the quotient and can attack the dividend at multiple places at the same time. Let's continue here. VM books do not seem to use this method. It's fast one and easy. In my opinion, it's fast and easy. Okay, it does not use any sutras though. Let's continue here. With next section here. Next section is divisibility by osculation. Okay, let's continue. Look at some first principles involved here. Let's continue here. First, adding or subtracting multiples of the divisor does not change divisibility. Let's continue here. Second, 2 and 5 are factors of 10. For divisors of the type 2 raised to the power I times 5 raised to the power j, so multiples of 2 and multiples of 5, we can add zeros. When add zeros to the right, we are multiplying by 10, and we can do that repeatedly if necessary and can get a number to become divisible by such a divisor. Okay, let's show you an example here. Example 1. 1 is not divisible by 5, but I can multiply 1 by 10 by adding a 0 and make it 10. So 10 is. Okay, let's continue. Another example. 1 is not divisible by 20. 20 is 2 times 2 times 5. Okay, but 100 is. So I can multiply 1 by 10 twice. I can add 2 zeros at the end, and then it becomes divisible by 20. Let's continue. Another example. 1 is not divisible by 16. 16 is 2 times 2 times 2 times 2. But 1000 is. So 1 is not divisible, but I can multiply 1 repeatedly if necessary by 10 to get a 1000. Okay, and that's adding 3 zeros at the right. And 1000 is divisible. So in these cases, when divisor was of this type here, multiples of 2's and multiples of 5's. Okay, number of 2's multiplied by number of 5's. If that's the type the divisor is, we can make that number divisible by such a divisor by adding zeros to the right, or by repeatedly multiplying that by 10. Okay, let's continue. When a divisor ends in 3, 7, and 9, we cannot make a dividend divisible by such a number by repeatedly multiplying by 10 by adding zeros at the right. Okay, let's show you an example. Okay, example 1, 13 is not divisible by 7, and neither is 130 or 1300. We cannot make it divisible by 7 by adding zeros to the right. Okay, let's continue. Example 11 is not divisible by 13, and we cannot make it divisible by 13 by adding zeros to the right. Continue. In such cases, we can replace is 130 divisible by 7 by is 13 divisible by 7. The two are equivalent. Let's continue here. We will be removing zeros on the right. That means we will be dividing by 10 by discarding zeros on the right in the process of determining divisibility. Let's look at what divisibility by osculation is. Let's continue here. We would be adding multiplier of a divisor to make the right position value 0. Okay, this multiplier has to work with any digit in the right place. Let's see what we are trying to do here. We need to compute a multiple of divisor times right place value plus right place value. Right place is a common factor in these two expressions here, on one to the left of plus sign and one to the right. Let's see what's happened. Okay, so right place time divisor multiple plus 1 has a 0 at the end, so must be multiple of 10. That means that this number divisor multiple plus 1 must be a multiple of 10 too. Okay, that means divisor multiple plus 1 must be multiple of 10. What does that mean? That means that divisor multiple must end in a 9. Okay, so we need to compute a divisor multiple of the divisor which ends in a 9. Let's do an example. Okay, to go through the steps. Example we take is 132 divisible by 7. Let's continue here. First is we got to find a multiple of 7 which is ends in 9, and that multiple is 49, which is equal to 7 times 7, and 49 does end in in 9. Let's continue here. Then what we do, we will compute a multiple to be added, which is 49 times 2, which is 98. Okay, we're going to add 98. Okay, okay. So when we add 98 to the 138 we had is 230. We have a 0 we were looking for. Okay, let's continue. Now we do have a desired 0 in the right place. Okay, observe. Multiplication by 49 is hard and it is Vedic math. We are in Vedic math where mantra is short and sweet, one line mental solution when possible. Otherwise, simplify as much. Continue here. It's 132 divisible by 7, same problem again. Now first we will replace 49 by 50 minus 1 by addition and by subtraction of 1. Okay? So we got 50 minus 1 times 2 plus 132. Okay, so let's see what's up. That's 50 times 2 plus 132 minus 2. Okay, okay, all right. So 2 minus 2 is 0. Okay, it is 2 and minus 2 will become 0. Okay, so the 2 minus 2 is 0. Okay, this 100 here, when we add 100 to 132, the carry is 10. We add the carry of 10 to the next digit on left, 3. That becomes 13. So it's a 1 and 13 here, and a 2 and a minus 2 will become 0. So, okay, so we get it. Let's see what happened. And the rightmost digit is this 0 here, 2 minus 2. We will divide that by 10 by discarding this 0. We would not change the divisibility by 7. We're looking for divisibility by 7 and dividing a number by 10 by discarding zeros on the right. It does not change the divisibility. Okay, let's continue here. Here example, if 13 is not divisible by 7, neither is 130 and nor is 1300. Let's continue with the example. Let's reiterate stress. First, obtain a multiple of divisor ending in 9. That multiple is 49 for a divisor 7. Okay, let's continue here. Second, use 50 minus 1 for 49, which is by addition and subtraction. Okay, let's continue here. Second, third, ignore minus 1. This minus 1 here, which changes the right position to 0, and we ignore that position anyway. Okay, let's continue here. Fourth, bring the carry from 50 times the right position is carry value is 5 times unit place, right place, to column on the left. Okay, so we would have 5 times the right place value to the, we would add that to column on left. Okay, let's continue here. Fifth, add the carry to the digit on the left, column on left. Yes. Let's reiterate again. Is 132 divisible by 7? What did we do? First, let me restate 2 steps needed to accomplish what we just discussed. Okay. First, multiply right column digit by 5. Okay, that's 5 times 2 is 10. Okay, let's continue here. Add the product to the digit on the column on its left. Okay, so we multiply right column by 5 and add that to column on left. Let's continue here. Okay, where did 5 come from? We got the 5 from 49. Okay, and then we got a second one more than before of 49. Then we use a 5 as a proxy for multiplication by 50. Let's do the division now. Is 132 divisible by 7? Let's do the osculation process again. Original number is 132. Okay, let's continue. Multiple of 7 to use is 49. 7 times 7 is 49. We use a multiple and 9. One more than before is 50. And proxy we will use is for 5. For multiplying by 50, we'll use a proxy of 5. Okay, let's continue here. So osculate stuff is 5 times right digit plus the left digit. 5 times 2 plus 3, which is 13. Okay, let's continue here. Okay, 13 is a little larger number and larger than 7. I'm going to subtract 7 from it and make it a 6. I'm going to reduce the 30 to 6 by taking remainder of 13 divided by 7. Okay, or I'm going to subtract multiples of 7 from 13 and get a 6 here. Okay, let's continue here. So we got smaller number 6. Okay, osculate again. 6 times 5. That's the osculation of 6 times 5 or 5 times 6 plus 1, 31. Okay, so let's get 31 here. Okay, let's continue. Now I get left with 31 here. 31 is not divisible by 7, okay, and neither is 132. So 132 is not divisible by 7. Okay, let's continue here. Okay, same example. Did you see what we do accomplish by osculation? Let's continue here. First osculation was 5 times 2 plus 3 equal 13. Let's see what we did. It includes multiply of 49 times 2 equal 98. Then add that to units placed. So 98 plus 2 is 100 with 0 and a 10 as a carry. Okay. Then add that carry to the digit on left to get 3 plus 10, 13. And divide by 10. Discard the 0 here by discarding 0 on the rightmost column. Okay. So this is all we did using a osculation method like that. Okay. Let's do another example here. Example is 144579 divisible by 7. Let's continue here. Original number is 144579. Let's continue. We're going to find a multiple of 7 which ends in 9. That's a 49. Okay, 49 is 7 times 7 and it does end in 9. So one more than before of 49 is 50. We'll use 5 as a proxy. Continue here. First osculation is 9 times 5 plus 7 equal 52. Okay, 9 plus the proxy 5 times 5 plus the number on left. 9 times 5 plus 7 is 52. Let's continue here. Okay, now 52 is too large a number compared to 7. 7 is what we are trying to divide by. Okay, so subtract multiple of 7 from 52 to get a 3. 52 minus 49 is 3. 49 we subtracted is 7 times 7. Okay, so we would get a 3 here. Okay, let's continue here. So we end up with 3 here. Let's do the osculation again with this 3 on right and 5 on left, which is means let's continue what we do. 3 times the proxy 3 times the proxy 5 here plus the digit on left, so just 20. We reduce that to 6. 20 minus 14 is 6. 14 is 7 times 2. We reduce that by a multiple of 7. 7 is the divisor. Okay, let's continue here. So we get 6 here. Okay, now osculate that again. We have 6 on the right column and 4 on the left. 6 times the proxy 5 plus 4 is 34, and we do that again, reduce that by 28 to get a 6. We get 6 again. Okay, now we are gone so far. We got 2 6's here. Now we're going to osculate that again. 6 times 5 plus 4 is 34. 5 is a proxy. 6 times 5 plus 4 the digit on left, and we reduce that again to 6. Okay, so we got another 6 here. Continue here. So 6 times 5, 6 times the proxy plus 1 is 31. So we got 31 here. Okay, 31 is not divisible by 7. So this 31 and neither is 144579. Example here is 1433719959 divisible by 49. Hey, I got this example from a leaflet prepared by Vedic Math Academy. Let's continue here. So number is 1433719959. Let's continue here. Multiple to use is 49. 49 times 1 is 49. It ends in 9. Okay, and one more than that is 50, and proxy is 5. Let's continue. First osculation is 9 times 5 plus the next digit here 5, 50, and we will reduce that to 1. 50 minus 49 equals 1. Okay, let's continue here. So we osculate these 2 digits and got a 1. Okay, let's continue now. Now we're going to osculate again. 1 times the proxy 5 plus the digit on left 14. So next is 14 now. Okay, let's continue here. Now we're going to osculate that again. 14 times 5 plus 9 is 79, and then we subtract 49 from here. We're trying to figure out if it's divisible by 49. So subtract 49 from here, we get 30. Let's continue here. Okay, now we're going to osculate this 30 and 1 here. Okay, 30 times 5 plus 1 on the left. Okay, which is 151, and we take away multiples of 49. We take away 3 times 49, which is 147, and reduce to 4. Okay, So we'll use, instead of 151 we got from oscillation, we'll continue with the 4 here. Let's continue, do oscillation again. 4 times the proxy 5 plus the digit on left, 27. Okay, now I got 27 here. Let's continue here. Now osculate that again. 27 times the proxy 5 plus 3, okay, 138. We'll reduce that. So we take out 98, which is a 2 times 49 from here, and we got 40. So we'll work with 40 to start next. Okay, so 40. Okay, now we'll continue again. Is 1433719959 divisible by 49, and we have so far osculated up to here. Okay, let's continue. So osculate again. 40 times 5, the proxy, plus 3 digit on left, 203. We take away 196 from there, reduce to 7. 196 is 49 times 4. Okay, let's continue. So we got 7 to work with. Osculate again. 7 times the proxy 5 plus 4. 7 times 5 plus 4 is 39. Okay, let's continue here with 39. Now osculate again. 39 plus 5 times 5 plus 1. 39 times proxy plus 1 on the left is 196. Okay, let's continue here. Okay. And 196 is 49 times 4 is divisible by 49. 196 is multiple of 49, and so is 1433719959. So we have just concluded that this large number 1433719959 is divisible by 49. Continue and stay with the same example again for a while. So far we have decided that this number 1433719959 divisible by 49. We went through the osculation steps, and last number we had is 196. Okay, let's continue here. If you could not determine that number 196 is divisible by 49, you can osculate that again. Let's see what I mean. Okay, that means I have 196 here. 6 times 5 plus the digit on left, 6 times 5 plus 9 is 39. Okay, let's continue. Osculate again. 39 times 5, 5 is the proxy, plus 1 on left is 196. Let's continue. So we started with 196. We osculated and came back with 196. If you start with 196 and end up with same number, after osculation, that number is divisible. So says Tirthaji. Okay, let's continue here. That means 196 is divisible by 49, and so is 1433719959. So if in doing osculation you end up with the same number as you started with, then that number is divisible. Okay, let's continue here. Okay, do some exercises now. Determine if the following numbers are divisible by 7, 14, 21, 28, 35, 42, and 49. Let's continue. First number 198948. Next number 331632. Next number 81480. Next number 1784161. Next number 2444296. Next number 1605828, and some more. Another example here. Okay. Problem is 2955303 divisible by 39. Let's continue here. The number is 299,55303. Let's continue. Multiple to use is 39. 39 times 1 is 39, and 39 does end in 9. And 1 more than 39 is 40, and proxy is 4. Okay, we're going to use 4 as a proxy. Okay, so first osculation is 3 times the proxy plus 0, 12. Okay, let's continue here. Next, now osculate again. This 12 on the right and 3 on the left. 4 times 12 plus 3 is 51. 51 is more than 39, and we reduce that to 12. Let's continue. Next osculation is 12 times the proxy 4 plus 5, 53. We reduce that to 49. 53 is more than 39, and we subtract 39 from here. Okay? Let's continue. Next we have 14 times the proxy 4 plus 5 is 61. We reduce that to 22 is take away 39, so we got 22 left next. Okay. Next is we osculate 32 and 9. 22 on the right, 9 on left. Okay, which is 4 times 22 plus 9, 97. Okay, 97. We take away 78, which is 2 times 39. 97 is too much. Not more than 39 is, so we reduce that to become 19. Let's continue. Okay, now we osculate again 19 on right and 2 on left. 4 times 19 is 76 plus 2 is 78. Okay? And 78 is 2 times 39. So 79, 8 is divisible by 39, and so is this number 2955303. Let's continue here. 78 is divisible, and so is 2955303. Do another example. Example is 150,799,73 divisible by 23. Let's continue. The number is 150,799,73. Okay. Okay, now divisible. We multiple to use 69. 69 is 23 times 3. 69 has a 9 in the end. 69 does end in 9, and one more than 69 is 70. And proxy we will use is 7. Let's continue here. Now we're going to osculate these two digits, 7 and a 3. 3 times the proxy plus the left digit. 7 times 3 plus 7, which is 28, and reduce that to 5. 28 is more than 23, and we get a 5 here. We subtract 23 from here. Okay, let's continue here. Now we're going to osculate this 5 on the right and 9 on left. So 7 times 5, 7 is the proxy here. 7 times 5 plus 9 is 44. Okay, and we will subtract 23 from here, we get a 21. 44 is more than 23, we subtract 23 from here, we get a 21. Let's continue. Okay, now we're going to osculate this 21 on the right and 9 on left. 7 is proxy, 7 times 21 plus 9 is 156. And we will reduce the, take away 138 from here, 23 times 6, okay, and get 18 left. Okay, let's continue. Okay, now we're going to osculate 18 on right and 7 on left, which is 7 is proxy here. 7 times 18 plus 7 is 133. Okay, now we will reduce that to get 18 here. Okay, let's continue here. All right, let's continue. So now we got 18 here. We osculate that again. 18 on the right and 0 on the left. 7 times 18 plus 0 is 126. Okay, we'll reduce that to get a 11. 23 times 5 is 115. We'll subtract 115 from here to get a 11 here. Okay, let's continue here. Okay, now we got osculate 11 on right and 5 on left. 7 times 11 plus 5 is 82. Okay, 82, and we reduce the 69 from here. 23 times 3 we subtract from 82, get 13 left. Okay, let's continue here. So now we osculate 13 on the right and 1 on left. Proxy is 7. 7 times 13 plus 1 is 92. Okay? But 92 is divisible by 23 because 92 is 4 times 23. So 92 is divisible by 23, and so is 150,799,73. Let's continue. 92 is divisible by 23, and so is 150,799. Please refer to Tirthaji's book. That book has numerous examples. Okay. Okay, let's see. Do some exercises now. Are the following divisible by 13, 26, 39, 52, 65, 23, 46, 69, and 92? Let's continue here. Okay. First number 305930. Next number 930281. Next number 3427164. Next number 2472808. Next number 4821310. Next number 5852263, and some more. Now let's go do some summary here. Let's see what we did so far for osculation. Okay, let's continue. It's the most quoted VM method for divisibility. It's the only VM method mentioned in Wikipedia. Okay, let's continue. Teacher's manual does not include it, and I have not found it mentioned in Glover's books either. Okay, let's continue here. We learned one method, and one single uses the same method in her book. We have discussed that method here. I have gone over this method, gone over some steps over and over because I found that it was a little harder to learn for me. So I hope I have made it easier for you. Okay? Tirthaji book describes two methods, and Ken Williams' book Discover Vedic Math does have both those methods. Let's continue. The main reference is our teacher's manual, and it does not have that osculation method. Vedic mathematics by Bharati Tirtha Krishnaji have two methods of osculation. Vedic math for schools have the by remainders method and does not have osculation method. I didn't find it. Vedic math made easy by Bhatia doesn't have osculation either. Vedic math for all ages has one method of osculation. Okay, and here is the reference for if you wish to learn more about divisibility rule. This is the reference to go to. Okay, it has many more examples and methods mentioned.